Hi, my name is Helen Gardner, and I'm going to be telling you guys how AZT can be used to knock down HIV and AIDS. So, a little background about HIV and AIDS is that it's a virus that attacks the body's immune system. If HIV is not treated, it can lead to AIDS, which is acquired immunodeficiency syndrome. And HIV is a human immunodeficiency virus, and there is currently no effective cure. Once people get HIV, they have it for life, but with proper medical care, HIV can be controlled. The virus can be transmitted through contact with infected blood, semen, or vaginal fluids. Within a few weeks of HIV infection, flu-like symptoms such as fever, sore throat, and fatigue can occur. And then this disease is usually asymptomatic until it progresses into AIDS. And then AIDS symptoms include weight loss, fever or night sweats, fatigue, and recurrent infections. And then I have a video that I'm going to play that kind of gives a little bit more background.
Here we have reverse transcriptase, which takes the viral RNA and using host nucleotides converts that viral RNA into a single strand of DNA. While it does that, it makes some random errors, which is characteristic of reverse transcriptase. It has very poor proofreading activity. That single-stranded DNA now is again reverse transcribed into a double-stranded DNA. At that point, another enzyme that has come in with the virus in the beginning, called integrase, essentially grabs hold of that double-stranded DNA and carries it through a nuclear pore into the nucleus of the cell. Within the nucleus of the cell, it finds the host chromosome, and the integrase enzyme makes a nick in the host DNA and allows for HIV to insert itself into the host chromosome. And that right there is what establishes lifelong infection.
Okay, so hopefully that gave a little background on some HIV and AIDS. And then this brings me into AZT. And AZT belongs to a group of drugs known as nucleoside reverse transcriptase inhibitors, or NRTIs. And it's a drug used to delay development of AIDS in patients infected with HIV. And here's a little slide on that. AZT is only active against HIV when the virus is replicating into proviral DNA. This is because the active compound of AZT, also known as zidovudine 5-triphosphate, and it has high affinity for an enzyme called reverse transcriptase, which is used by retroviruses such as HIV to replicate viral single-stranded RNA and into proviral double-stranded DNA. And then reverse transcriptase incorporates AZT into growing strands of HIV. Proviral DNA and DNA synthesis and replication are terminated. And then here I have the molecule of AZT, and the enzyme reverse transcriptase of retroviruses catalyzes synthesis of a DNA genome. And as noted previously, proviral HIV DNA integrates into the normal cell genome, and upon expression results in HIV infection. AZT may be classified as a prodrug in that the parent compound is converted by host cell thymidine kinases to 5' mono, di, and triphosphate derivatives. These phosphorylated derivatives are then incorporated into proviral DNA, since reverse transcriptase uses AZT as a substrate. As a consequence, normal cellular 5' to 3' phosphodiester bonding is prevented and DNA chain elongation terminated as a result of the azeto group, which is right here is the azeto group of AZT. And then this process results in preventing new HIV virion synthesis. So this brings me into the mechanism of nucleoside reverse transcriptase inhibition, AZT. Well-known RT inhibitors include AZT. This shows an example of ordinary reverse transcription, and then these are examples of nucleosides. And then these act as nucleoside analogs, and in a sense, they pretend to be a nucleoside so that when RT is creating new DNA, like right here, it accidentally inserts a molecule of AZT rather than a nucleoside. So you can see right here, the AZT accidentally inserts a molecule instead of a nucleoside. It inserts the AZT instead. And then right here you can see that the DNA synthesis cannot continue. So this terminates the DNA chain and no more can be appended to it. So there's AZT and the DNA synthesis cannot continue. So I hope this was a good example of how AZT can be used to knock down HIV and AIDS. And thank you.